Question 8.
Yeah.
Question 8.1. It says determine the equation of a second derivative of x.
Yeah.
So, Mr. Ish, this one. I started by finding the gradient of the coordinate.
Okay.
Of
M
6
is
and
going to be given as, what did you say? You said 6 minus 0, ne? All over.
Means 0 minus into minus 1.
The other one is what? 0 into minus 1.
Yes.
And then you got what is your answer?
6.
Positive or negative 6?
Positive 6.
Positive 6. Is it positive 6? So it was. Kind of the coordinates here, it's 0 is to 6. Ne? And then the coordinates here is
Yes.
minus 1 is to 0. So we say 6 minus 0. It's fine, that one. Or we're supposed to say
Yeah.
0 minus 1. Or minus 1. Or, okay, it's minus 1. And then the gradient, when it makes sense, it makes. So you got 6. Okay, Dina, we'll give you a mark for that. What else?
And then I looked for C.
You look for C. So you said y is equal to 6x plus c.
Yes.
How did you look for c? Which point did you use?
I used 6.
You use 6. So we have 6, which is going to be 6 multiplied by what is x?
0.
It's 0. Plus c. What is c then?
Yes. C is 6. Positive C.
We could have just calculated the m and say this is the y-intercept. Okay. Therefore, y is equaling to, I think it's 6x plus 6, like
Plus
this.
C.
Okay. How many marks for
Yes.
this thing? 2 marks. It's 2 marks. Okay. So we'll give you 1 mark for m and then 1 mark for the equation. Okay. Next, Dinero. They say write down the values
8.2.
of x of the point of inflection.
Yes.
Yeah.
So we know that the second derivative of f of x is equals to 0.
Oh, so you want me to say 8.2, you want me to say 0 is going to be equaling to 6x plus 6.
Plus C. Yes.
Okay.
And then you transpose, take 6 to the other side.
It says you have minus 6, which is going to be 6x divided by 6. Divide by 6. It says x is going to be minus 1. So it means it's this one here. We could have told them this is the x value of the point of inflection.
Yes.
Okay, we get, I think it's 1 mark this thing. How many marks? It's 1 mark. It's 1 mark. Yeah, it's supposed to be 1 because we could. It's minus 1.
Oh, yes, it's minus 1.
Yes. Okay, 8.3 Dinawa. What do you think on this
8. I think that the second derivative of f of x should be greater than 0.
6x plus 6 is going to be greater than 0. This is 8.3. Sure.
Then you transpose.
Okay, we have 6x is going to be greater than minus 6.
Yes. Then x is equals to negative 1.
X is greater than minus 1.
Oh, yes.
Okay. So how many marks was that one?
2 marks.
2 marks.
I got the calculations.
Mm.
X is going to be greater than negative 1.
Why did you say that?
Because f prime of x is positive or x is greater than negative 1.
So you say if because this thing is above the x-axis here.
Yes.
So it means which the graph is concave up.
Yes.
So where it's negative, you say it's concave down.
Yes, because that's all you know. If f prime of x
is positive.
yes.
Yeah. So you could have said, okay, here we have x greater than minus 1. That is why you can still get 2 marks here. I think they will give us a mark on the final answer. The rest will be implemented. Yeah. Okay, Khozo, you say you want to take 8.4. Thank you, Dineone. Khozo is promising to take 8.4 for us. Okay, Khozo, yeah.
Or knowing that Dineo 8.4.
No, do it.
Sure. Then just go to 8.2. Yeah, 8.4.
8.4. You go to 8.4. Okay. Now, 8.4, they say show that P is equaling to 1 and Q is equaling to 3 and R is equaling to -9. Ne? So firstly, we're going to take the original equation, again, which is that above again. Now we're going to differentiate it. If we differentiate it, we're going to have f prime of x equaling to 3px plus 2qx plus r. Sorry, now we're going to differentiate it for a second time again because the graph given there is the second derivative of f again. Now this is going to be 6px plus 2q again. Then the r is going to be 0. Okay, now, so ladies and gentlemen, the f prime of x that we f prime prime of x that we found in 8.1 is the same as the f prime of x in this one, this 6px plus 2q again. Now I'm going to tell them what f prime prime of x, that one, and the red one, they're equal. So automatically 6p is going to be equal to 6 from 6 8.1 again. So if we're having 6p equal to 6, we're going to divide by 6 both sides. That's like p equal to 1. Then 2q is also equal to 6, which is the c from the other equation again. And then 2q, if 2q is equal to 6, we're going to divide by 2 both sides, having q equal to 3. Sure. Now we found out now. Ladies and gentlemen, we had a confusion last time again. -1 is the x coordinate of the turning point of the gradient or the graph of f prime of x again. Now it is not the x it is not it is not the Watson, or it is not the value of the x-intercepts, man. It's the x value of the turning point. Now, if it is the x value of the turning point of f prime of x is not equivalent to 0. So ordinarily, the y value of the turning point is 0, which is wrong again. Now, barking, yo, Mr. Explain it, this one.
Okay, so we were told the gradient, this is the part of the gradient. So the gradient is given here. They say the graph of f is decreasing where x is greater than t, but x is less than 1. So if you were to think about this thing, it means we have something that looks like this. So we have the turning point number 1, and then we have turning point number 2. Let's say turning point number 1, we have 1, and then we say turning point number 2, we have t. Or it can be t and 1, it doesn't matter. But we're supposed to start with t because it's decreasing. So the graph is decreasing up until it gets to the turning point. And then we have t, and then we also have what? We also have 1. Yeah? Now here's what we know for sure. We know here it's a turning point of the f of x, which is the mother graph. Now at the turning point here, we know the gradient. So I'm going to tell them which x is 1, but our gradient is going to be 0. Here we are sure of that because this is the turning point it is the turning point of the cubic function. So what happens at the turning point of the cubic function, we know with the gradient is going to be equal to what? To 0. Yes. So this one here, the reason here, this one was the turning point of the parabolic function. So this is just the turning point of the parabolic function. It was not the turning point of the cubic function. So we need the turning point of the cubic function because we know the gradient of the turning point of the cubic function is the one which is going to be 0. Ne? So we are going to say, let's sub on this equation, which is f prime of x, this one. And then we're going to have f prime of x. We know what is q. We already know what is q. Then it means our graph is going to be equal to 3x squared. Plus, we know what is q. Even if, I can't say even if we couldn't get it, because it's the same equation. Yeah. So it's plus 2 multiplied by 3, it gives us 6x.
6x, yes,
plus r. Ne?
But we know x.
But we know x. Ne? Yeah, the x, it's like we have x and t here. We have x and t because decreasing turning point, it can't decrease unless it's at a turning point. That's very key. So we're going to have something that looks like this. We're going to have f of 1 is going to be equal to 3 multiplied by 1 all squared plus 6 multiplied by 1 plus r. Ne? But f prime of 1, it's the gradient at the turning point. What is the gradient at the turning point? The gradient at the turning point is equal to what? To 0, which is going to be equal to 3 plus 6 plus r. 3 plus 6 is going to give us 9. Take the 9 to the other side, it says we have minus 9, which is going to be equal
To
r.
Mr. 8.6.
You want-
8.6 loan, I get justice or is sharp.
Okay, so we can look at 8.5 and then 8.6. 8.5, we're supposed to get the value of t.
We did it because using these values of R current relation so the 8.4. So very sharp.
It's fine.
Yeah, it's sharp.
Are we all good, guys?
Yes.